evening, guys. Today we're going to discuss about a topic which is very unique and not exactly taken up by many professors and professionals. We're going to talk about how machine learning based approaches are applicable in automating FPV racing and freestyle. Let me break down each term for you. Machine learning, or ML in short. And machine learning, I think many people here already know what machine learning is. Uh, on a brief record, machine learning is basically when someone writes a code and that code learns from external factors and outputs and creates its own brain algorithm in its brain, which which through which it can automatically come out with its own decisions and its own results. Approach in automating FPV racing and freestyle. I'll come to that later. So basically, the vision of this topic includes how a race, how a drone race can be automated, and not just the racing part of the drone race. There are many factors which affect a drone race, like the building part, the training part, and how pilots are trained, how the simulators and the firmwares are developed, how is automation how can automation rather play a part in it. That is the vision of this topic. So if you look into this presentation or this video, what do you want to call it, there will be some key terms which we need to know what exactly they mean. Number one, domain randomization. So domain randomization is basically when in layman terms, domain randomization says that if you are given an environment, there is a key to every environment, an object, if I may, which which can be held as the point of reference to each and every other object in the environment. For example, take a room. A room always generally, I assume, has a tube light. So that tube light can be taken as a point of reference to map the entire room, the distance from each object to that tube light, the size of each object to that tube light, etc. So domain randomization is that in respect to FPV racing in specification, we are looking for race gates. Race gates are basically something through which a drone flies. So basically that is domain randomization. FPV is first person view, which we'll come on later. Process automation. Process automation is basically whatever we are doing manually is automated. That kind of, I think, comes under AI. So yeah, active cloud technology. That's the row, by the way. Active cloud technology is basically trying to uh, merge cloud into automation of drone swarms. I know this is a bit far-fetched, but I think it is very much possible to get to use cloud technology because it is one of the largest open source and in my opinion very useful tool that we have been given. So I have come up with a few ideas wherein cloud will use this. Machine learning, well, yeah, I think I've already explained machine learning above. So yeah, these are the main keys terms, and I hope you are clear with most of them. We will go through this flow chart wherein wherein I think this will cover each and every topic in our presentation, and at the same time it will be more organized. Or I could just rant on and on about just one topic and then jump to another and then jump to another. I could do that. I'm still doing it, but then I have a certain way of doing it right now. Cool. Just whoever wants to take a screenshot here can. I don't care. So let me clear on what exactly is FPV. FPV means first person view. When a person refers that मेरे पास एक FPV ड्रोन है. I have an FPV drone and I fly. I'm a pilot. I do freestyle. What they mean is that basically they have a drone wherein wherein you you have a bird's eye view of what the drone is seeing. What generally लोगों के दिमाग में क्या आता है जब हम ड्रोन बोलते हैं तो people are like yeah, it is a white colored four propeller drone जिसको we see and fly. Like we're seeing the drone with our eyes and we're looking at the drone and we're flying, right? So FPV is similar to that, but then something is very different. And that is you don't see the drone while flying. You see what the drone is seeing. That is called the eagle's eyes view. The drone has a camera in front of it or on it, and using a pair of FPV goggles, something like a VR goggles, the drone transmits what it is seeing through that camera in real time with extremely low latency to our goggles, and we fly using those goggles. We fly by seeing what the drone is seeing. So that is basically FPV. You can put an FPV setup on any item. Like you can put an FPV setup on a remote control car or on even on a dog. Who cares? But then in this particular topic, we are focusing on FPV drones. So coming to the topic here on screen, what exactly is FPV racing? FPV racing is basically a set of drones. It's basically an event where lots of professional pilots come together and compete on an official professional racetrack using their FPV drones. They reach speeds crossing 250, 300 kilometers per hour and extremely fast reflexes. Uh, the main question here is that because there is such an extreme requirement of speed and control reflex from a human pilot, can a machine actually replicate it? Is there enough technological advancement in today's world to actually replicate that? Let's answer that question in a while. Cool. So, coming to the first topic, coming to the first technique, the first tool, in other words, that we can use is the line creation technique. So basically, what a line creation technique is in my paper that I've written is that okay. First of all, let me divide each and every tool into three categories. Let's have an input, let's have a process, and let's have an output. What input means is that the drone needs to recognize its environment. The process is the drone needs to calculate and compute what all is there in the environment and its characteristics, realize its characteristics and stuff. Output is basically using that information from the process and the input to actually give commands to the flight controller of the drone. Flight controller is basically the main brain of the drone. So that each tool will be divided according to these three conditions: input, process, and output. I hope you can see my hand. Yeah, never mind. So line creation technique. Line creation technique is basically whenever you are racing, uh, a pilot strictly follows a race line. What a race line means is that it is the shortest a race line is the shortest path through which a drone can physically fly in real life to cover the distance in the minimum time. So basically, I think race lines are also a concept in normal F1 races where the overall speed should be greatest and like at the same time the turns should be taken care of because we know that there's a lack of friction on the ground. So if we are moving at a high speed on a turn, then there's a chance of the car toppling. So a similar concept is there in drones also. If we go at high speeds in a turn, there is a chance of the drone drifting or going out of control or handling prop wash, etc. So basically, that is what a line grading technique is. What what pilots do in today's day and age is that they run through the whole race course for an hour or so. They practice and practice the same race course for an hour, and they create a mind map of a line of the race line. So here, what we can do is that instead of letting just letting the drone go and recognize all the gates and stuff using uh, various algorithms which will take years to develop, we can first just let the drone learn the gates, learn the whole course, and then create its own line. Once the drone creates its own line, during the actual race, the drone will have absolutely no problem in moving through the course fast, because during the actual race, the drone will not have to compute anything. It already has a set path towards the whole course. Using its GPS module, it can use that set path and use that set path as fast as it can. Right? It's a foolproof plan. So using coming to the three characteristics, the input is set already before the race. Processing is also done before the race. The output is also done before the race. So the actual work that the drone needs to do is before the race. During the race, the drone needs to do nothing; it just needs to fly as per the command. So that is line creation technique. It is it. I think if people work upon this, this technique can actually oust all other human pilots. Using external sensors. Okay, so this is a very interesting topic. TEDx has already, I think they have done वो लोग जो भी करते हैं that presentation or stuff. YouTube, I've seen that on YouTube. They did that. They did this external sensor wala thingy. So what they did was they had a room, a closed room, उसके अंदर drone था, and then the drone did not have any sensors on it. It did various sorts of crazy stuff like balancing a beam on itself and following a white colored ball and playing catch and catch with each other. It's crazy crazy stuff. But then the drone itself did not have any sensor on it. The room had all the sensors and they were sending commands to the drone. So that is external sensors, and the best part about this is that it saves a lot of weights, a lot of electronics, and a lot of real estate on the drone. And this is especially important in case of a racing drone, because a racing drone needs aerodynamic stability, and it needs to be as lightweight and as durable as possible. The least number of boards or electronics it has on itself will save utna zyada weight, and at the same time have more durability, because there is less chance of stuff breaking. Yeah. So that external sensors. Coming to domain randomization is how you do line creation technique. It is the preconception of a line creation technique. Line creation technique में आप पहले सब कुछ कर लेते हो, बट करते कैसे हो? वो डोमेन randomization से करते हो. You identify all the gates, you identify the course, and mark some checkpoints, mark some keys, and उसके वाया आप जाते हो. So that is basically domain randomization in a very brief manner. Coming to the most important, most not important, I'd say, but the most fun part, automated drone swarm. I know everyone. Uh, Fuck. Yeah, who cares? I know everyone knows what a drone swarm is, right? So, I think at least you have an idea. A drone swarm is basically when you are going in the sky, but then you see thousands of dots making some shape in the sky. This scene, if you have not seen it, you should. A drone swarm is basically many drones, many drones. in this case more than two, but in general many drones flying together in a formation, communicating with each other, or given through central command. Basically, in this field, in FPV field, a drone swarm can be implemented using the cloud. How a cloud can be fed a cloud can be fed the algorithm of a race course, the line basically. The cloud can be fed the line, and then e- each drone can be communicating with the cloud itself to execute the cloud's commands and use it in the actual race. So basically, on the air, in the air, there will be 5 to 10 drones following the exact same commands. How cool is that? So basically, yeah, that coming to FP freestyle, I think this is one topic wherein autonomy is very tough to implement. Why is it tough to implement? Because unlike racing, FP freestyle is very it's not fixed basically. In racing, there are fixed lines, there are fixed checkpoints through which you need to go. FPV freestyle is not that. In FPV freestyle, you basically do what your mind tells you to do. You basically you don't have a fixed amount of कि तुम्हें इतने टाइम पर you have to complete this course or you need to go through this part then this part. FP freestyle is not. FP freestyle is what comes to your mind, what is happening with your train of thought. It is used to express yourself. According to Rotor Riot, which is the largest community of FPV in the world right now, FPV freestyle is all about expressing yourself through the movement of your drone flowing through a landscape or structure and pulling off impressive tricks, gravity defying tricks. It is this the important part is it is all about expressing yourself. And if you think about expressing yourself, then I think the main part of artificial intelligence or machine learning in it is kind of rendered useless, isn't it? But then each and every discovery or invention was considered useless before it was actually invented. So who knows? This may take off. Anyways, there are some ways in which FPV freestyle can also be automated. The first one is partial automation. DJI is a great example. How they have just come out with a product called the DJI FPV drone, wherein it is still a freestyle drone, but it sort of has a certain level of autonomy in it. How? Because it suppose you're going you're going to hit a wall. The drone itself veers away from the wall and gives you a straight path again. If you're flying both shaky and not exactly straight, then it will try to keep the video extremely tight and straight. That is a part of freestyle, but at the same time, it is also automated. How great is that? Secondly, geofencing. Geofencing is implemented but not in freestyle currently. What geofencing exactly is that it basically prohibits the drone to fly from a certain sphere of area. Here, geofencing can be autonomously shifted and be allowed to change its shape according to the pilot's needs. If the pilot is a beginner and the algorithm detects that the pilot cannot be flying in a certain manner, then it will geofence, it will restrict the quad, it will restrict the drone to actually fly how the pilot is flying. Lastly, how to go around the free will problem. What is the free will problem exactly? What I told basically, what the main part of FPV is it expresses yourself. It runs. It is being commanded by your train of thought of your own brain. How do we get a train of thought in in an algorithm? That's the biggest question, which will remain a question I cannot answer. That will still remain a question for decades. I don't know if I don't see a motivation for a person to actually develop a fully automated freestyle code because that will kind of defeat the purpose of freestyle. But then if that is there, then I don't know. Great. Imagine a drone just doing freestyle and no one's controlling it. It's just minding its own business. It's like having its own brain. How cool is that, dude? Anyways, there are two ways to address the free will problem. एक तो पहली बता दी था partial automation. The other is there's still a question. I'm not answering this. I'm just giving a hypothesis that this is possible. So what is convolutional neural network? This is a काफी complex a topic, but then the gist is basically divided into three parts. Spatial evaluation. A spatial evaluation is basically using and assimilating and convoluting its environments and then using the details in it and storing the details in it and basically recognizing them. That can be used as a part of domain randomization also. Obstacle detection and obstacle distinction are also are also very important parts of this of CNN, wherein using neural networks. What are neural networks? Neural networks are basically interconnections in a brain. What are convolutional neural networks? Convolutional neural networks are basically neural networks, but then in a computer. So yeah, you use optional detection and distinction to basically judge whether this tree is worthy enough to do a veggie style loop or a Maddie flip, or is this building or is this bando good enough to do a power loop or inverted yaw spin? Anything that can be done by convolutional network in orbit. So applications in an FPV race. Number one, next gen simulations. How? Partial automation again and augmented reality. So next generation simulations, basically what that is that instead of partially automating a real drone, which can be risky and can have a lot of bugs in my opinion, I think it is safe to say that using it in a simulator first will be a great choice. Why will it be a great choice? Because it will save the first 100 or a first 1000 crashes of any FPV pilot. And also, in my opinion, it will increase the learning curve of any pilot there. Pilot training. It is basically based on augmented reality. How imagine you have FPV goggles in your head, and then there is a race line. But then instead of imagining the race line is literally visible on your goggles. That is basically augmented reality. How cool is that? How is that possible? Is basically to use CNN to create a race line automatically. The external sensors use the environment and create a fixed path on the race course. And when anyone wears the goggles, the race line is placed upon the real life image that you see, and the pilot tries their level best to fly using that. It has so many advantages. We think it makes the training time of a pilot faster. From it can bring the pilot from 1 hour to 15 minutes to train on the race course. It will make the pilot more confident. They can push the throttle as much as they can, and of course improve the time per lap because of that. Lastly, not lastly, there are two more left. Software applications. There are so many softwares on firmwares, as for a correct term. There's so many firmwares that exist for drones. Beta Flight, KISS, InnoFlight, iNav, Patek, Clean Flight, Open Flight, Rio Flight, Nova Flight, and I have lots of them in my mind. But then अभी बोलूँगा तो everyone will report. They probably are anyways. So software applications can be further improved by using black box data from the drone automatically and using a using an automated PID looping technique. The proportional integral and derivatory of the flight controller can be automatically adjusted using the black box filtering data of the drone. Why didn't anyone think of that by then? I have no clue. If that is implemented, I think that will be the best. Anyways, uh, lastly, spec to spec racing. What does that mean is that using cloud technique, using cloud automation, imagine there are 5 drones in a race course, and you need your company, and you need to know which you have certain models and iterations of different drones. You need to know that which drone is better, like which build is better. आज के ज़माने में how do you test that? You test that by giving one pilot to one drone and then checking the time lapse. That is that does not give the exact result. If you use the same pilot for each and every drone, that does not give the same result because every pilot will perform differently, and because of that, the results won't be as accurate. The get around to that is that if every drone is given the same commands, exact commands at each and every moment, would not give the exact result also, you know. So using cloud automation, 5 drones on the race course can be given the exact same commands at every single moment, at every single hertz of the receiver. Then you can easily check which drone is better, which compatibility is working, which software is better, etc. Conclusion. Is it possible? I think it is possible. I have been building drones for quite a while, and I think I'm kind of surprised that why has no one thought of this before, and why is no one working on this. I kind of know why there's no one working on this because it's a hobby level field, but then I think it is very well possible with the correct technology. There are leaps and bounds ahead in stuff like mobile applications and web development and game development, and I think this is also something which is neglected and can be worked upon. Thank you.